Jai Hind everyone. Today we are here to explain a topic in a data structure, that is queue. What is queue and what are the applications of queue, where we are the used and what are the type of the queue. So before we start, myself is Anuj Kumar. I am the assistant professor in computer science and engineering department in Akgec Girl Engineering College. So today we have to be discussed a topic, queue in the data structure. So firstly, what is queue? As we have to be discussed before, queue we have to be start stack and its applications, and where we use the stack. The another linear data structure is queue. What is queue? In a stack we have to be insert or delete the element only at the one end, but if we have to be insert and delete the element at the both end, that is known as a queue. So as we say that queue, what is queue? It is a linear data structure and it is open at the both end, means we have to be insert and delete the element at the both end. One end we have to be perform to insert the element, at the other end we have to be delete the element from the linear data structure. So that linear data structure is known as the queue. It is also known as the open-ended queue. And when we have to be perform the some operations, and it is also known as first in first out, or we can say that it is based on the FIFO operations. First in first out means when we have to be insert the first element, so which element is deleted first? That is the first element. We have to be define a queue to be insert all the elements in the linked list, and we have to be define means layer. Means when we have to be insert the element in a queue, so that a point is known as the layer. Means when we have to be insert element, so it is known as the layer, and we can say that its function is known as the enqueue. Means enqueue is a operation in which we have to be insert the element in a queue. Same when we have to be delete the element from the D queue, it is known as the another end, that is known as the front, and we have to be known the operation is performed at the D queue. So when we have to be insert the element in a queue, so that is we have to be done from the rear end, and when we have to be insert the delete the element from the queue, we have to be use the front, and that function is known as the DQ. And where we have to be insert the element, so that function is known as the NQ. So we have to be apply the two operations when we have to be insert or delete the element in a queue. One is NQ to insert the element, and one is DQ to delete the element. So again I repeat, when we have to be delete the element, we use the front, and when we have to be insert the element, we use the rear. Here there are the, if we have to consider this is a queue, so we have to be perform some operations as I discussed, that is NQ means we have to be insert the element. Another one is that is the DQ means we have to be delete the elements. Create is used when we have to be create the queue, same as we have to be discussed in a stack. Similar here is empty, we have to be check the queue is empty or not. And next one is the we have to be define the size of the queue. So there are the some operations where we have to be perform insert the element, NQ delete the element, we have to create a queue, we have to be check the queue is empty or full. Similar here we have to be check here it is full or not. We have to be apply is empty, and we have to be apply the is full. And next we have to be define the size of the queue. So these are the some basics operations that we are defined on the queue. How it will be performed in first out principle. Suppose if we have to be consider a queue, that is if I am mention here its name is queue. So firstly we have to be define the size. Suppose it's just some missing, this is 1, this is second, third, fourth and fifth. So here we have to be defined, suppose I am taking a queue that has a size of 6. So means it has been create a 6 element block in the memory. So it means there is no element in the queue. So firstly we have to be define the value of what is the value of front and what is the value of rear. Means first element is inserted 0. If there is no element, then we have to be define. It means if queue is empty, then we have to declare front equal to -1 and rear equal to -1. These both conditions represent that queue is empty. Similar here, if front is -1, rear is -1, means there is no element in the queue. It represents the this. Next one here, now we have the queue is empty. Now we have to be insert the element one by one. Now suppose we have to be insert an element, that is A. So where it will be go? It will be goes to the first element. Right now we have the two value, that is front equal to -1 and rear equal to -1. When we have to be insert the first element, when we have to be insert the first element, the first element is goes where? 0. So it means we have to be increase the value of front and rear. Both we have to be increase. Similar here, if front 0 itna, when we have to insert the first element, so both rear and front are changed, means we have to be increase the value of front and rear. So in this condition, now we can say that our front equal to 0 and rear equal to 0, this condition. Again I repeat, when we have to be insert the first element, so when we have to be insert the first element, we have to be increase the value of front and value of the rear. Now second condition, now we have to be insert the element B. So in the queue, that is a queue of size 6, so it has already one element. Now here front equal to 0 and rear equal to 0. Now when we have to be insert the element, we can increase the value of rear only. So in this condition means front is equal to here same at position 0 and we have to insert the element, that is B. So we have to be insert rear equal to rear plus 1. So in this condition rear equal to 0, so that is 0 plus 1 means rear equal to 1, this condition. Similar here, if suppose we have to be insert the C, D, E and F. So firstly we have to be insert the element C. In this condition front equal to 0, we cannot be change the value of front. We have to be change the value of front only when we have to be insert the first element. After that we have to be insert the change the value of rear, because we have to be perform the NQ operations from the rear end. Now what we do, we have to be here in this condition rear is 1, so what we do, we have to be in rear equal to 2, means we have to be done rear equal to rear plus 1, then we have to be insert the C. Again we have to be insert D, so again we have to be insert the value of R. So now R equal to R plus 1 means 2 plus 1, that is 3, so we have to be insert D at position 3. Now we have to be insert E, again we have to be change the value of R, that is R equal to R plus 1. Now again we have to be insert and R equal to R plus 1, so means here. So in this condition here, what condition is exist? Front equal to 0 and rear equal to 5. Means in this condition, if there is no element in this queue, there is no element, there is no space in the queue, means this queue that is known as queue is full. Clear? So what condition is full? So it will be represent when rear, where rear is rear equal to 5, means rear equal to क्या हो रहा है हमारा, that is max minus 1. Max minus 1 equal to R equal to maximum size कितना था, size is 6. Q का size हम कितना लेके चले थे, that is 6. तो now 6 minus 1, that is will be equal to the 5. So here if a Q is full, so what is the condition we have to be write? Ki rear equal to max size minus 1, or in other words we can say that if rear equal to max size minus 1, then we have to be print the Q is overflow. Clear? Similar, if we have to be same, if we have to be apply here ki now we have to be delete the element, so we have from where we have to be perform the operations from the front end, means we have to be apply the DQ operations. So when we have to be apply the DQ, what element will be delete first? Where is front, and front is equal to 0, so that we have so define Q is a first in first out. जो हमने लास्ट इसमें यहाँ पे अभी डिफाइन किया था कि Q मेरा ऑपरेशंस कहाँ पे परफॉर्म करता है, दैट इज फर्स्ट इन फर्स्ट आउट. मींस कि इस कंडीशंस में कौन सा एलिमेंट इंसर्ट हुआ था सबसे पहले, ए, तो डिलीट भी कौन सा होगा, ए. सो वी कैन से दैट कि Q is performed on the basis of first in first out. Simple, we can be the example of the railway reservation system. Okay, so now when we have to be delete this A, so what we do, we have to be increase the value of front. Now here front equal to means front equal to 1 and rear equal to कहाँ पे है हमारा 5. Again if we have to be delete the element means which element is deleted, where we indicate the front means we have to delete the element B. When we have to be delete the element D, so we have to increase the value of 2. Similar we have to be delete C, so we have to be increase the value of front. Now we have to be delete next value, that is E, so we have to be the 4. When we have to be delete the value of E, so it means we have to be increase the value of 5. Means now if there is only one element, if we have to be right here, we have to delete A, B, C, D, E, and here we have only one element. And if what it indicate means front and rear both value are equal. So we can say that if front equal to rear, or when front equal to rear, it means that Q has only one element. So similarly when we have to be insert the first element, so we have to be change the value of front and value of the rear. And when we have to be delete the element, so what is the condition? Front equal to rear. So it means that Q has only one element. When we have to be delete this element, this element, so what happen? Our Q is empty. Or what is the condition of empty? Means front equal to -1 and rear equal to -1. So it means when we have to be delete the element and one condition arises when front equal to rear, that means that Q has only one element. And when we have to be delete this element, so Q is empty. So we have to be define front equal to -1, rear equal to -1. It means that Q is empty. We have to be defined in here. Q is empty. So what is the condition? Keep front equal to -1 and rear equal to -1. Same here when we have to be delete the element and we have to be delete the last element, means front equal to rear. What is the value of front? That is 5. What is the value of rear? That is 5. Means both are equal. That means Q has only one element. And when we have to be delete this element, so Q is empty. And what is the condition of empty is rear equal to -1 and front equal to -1. We have to be perform both operations on a Q. When we have to be insert the element, we call the NQ and it will be performed from the rear end. And when we have to be delete the element, we can call the DQ and that will be performed from the front end. Okay. What are the characteristics of the Q? Q characteristics are Q can be handled in the multiple data. Means one end we have to be insert the element and the other end we have to be delete the element. So means where the both end we have to be perform the other operations. Second one, we have to be access at the both end, and when we have to be access both the end, so it will be faster and flexible in comparison to the stack. So when we are doing the programming or write the C functions of the Q, or means when we have to be apply the InQ and DQ operations, so we have to be define some. Firstly we have to be define a Q, then we have to be define the front, and we have to be define the rear. Means in the starting we have to be define suppose a Q, suppose that size is 10, so we have to be define a Q. Second one, we have to be define the front and rear, and also we have to be initialize their value front and rear. There is no element in the Q, so by default we have to be defined as rear, that is front equal to -1, rear equal to -1. So when we have doing the programming of the Q, or we have to be implement Q, simple Q with the help of the C, so we have to be define the three things. Firstly we have to be define the Q. Second one, we have to be define the value of front and the value of the rear. Now we have to be given the various type of the Q. So there are the various type. First one is known as a simple Q, or we can be say that the linear Q. Second one is the circular Q. Third one is the priority Q, and next one is the double-ended DQ. Now we have to be here. We have to be discussed means linear Q. Linear Q means we have to be perform the operation only in the one direction. Means suppose if I have a create a queue that is 0, 1, 2, 3 and 4, and we have to be define this queue that is a size of 5. So here we have to be again define the value of front and value of the rear, means it means that queue is empty, there is no element in the queue. So when we have to be insert to delete, when we have to be insert, first element where is, that is A, next element is B, next C, D and E, means we have to be perform all the data in a directions. So we can be say that the DQ. Same here, if we have to be delete the element, so we can be perform only in the one direction. So we can be say that it is a simple queue and it is a linear queue. There are the some we have to be discussed later ki what are the advantage and disadvantage of the linear queue. Similar, what is circular queue? If suppose this is a queue of size 6, if last element is connected to the first element, so it is known as a circular queue, means it is also defined just like as a circle. When last element is connected to the first element, that is known as the circular queue. And what is priority queue? Every element has a priority. Every element has a priority, and we can be perform the operation based on their priority. And what is the next is double-ended DQ, or we can be say that the DQ. If we have a queue, this is we have a queue, and this is the front end and this is the rear end. When we have to be perform the both operations on the both side, means we have to be right now अभी हम क्या कर हैं, only delete from front and insert from rear. Now if we have to be apply the both operations from the both end, so we can be use the DQ, means we have to be insert and delete element from the front. Similar here, we can be insert and delete the element from the rear, means we have to be apply the NQ and DQ operations from the front end as well as from the rear end. So that queue is known as the double-ended DQ. Clear? So we have to be discussed here one by one what is queue and what are the DQ. So we can be define the operations here. What is right now we have to be clear here what is the simple queue and we have to be the linear queue, where insert we can be insert only at the one end and that is known as the rear. Similarly, we have to be delete the element and we have to be delete the element from the one end, that is known as the front. This is the example. Suppose we have a queue. If there is some element in the queue, that is front is indicating at this and rear is indicated at 6, means front equal to 2 and rear equal to 6. Now if we have to be insert the element in this queue, so we cannot be insert the element. Why? Because we have to be insert the element from the rear end, and rear is represent to 6, means that is the max minus 1. So there is no another space in the queue. So we cannot be insert the element if rear is indicating to the max minus 1. So in this condition we have to be defined what is the, this is the queue is full, and what is the condition if rear indicate the max minus 1. But we have to be space in this queue, but we cannot be insert the element. Why? Because we have to be insert the element only one end, and that is known as the rear. And where is rear? Rear equal to max minus 1. It means it has the maximum size. It will be indicate the last position of the queue, that is the max minus 1. So in this condition, queue is full. Same here we have to be perform. What are the operations? We have to be perform the operation of NQ. We have to be perform the operation of DQ. We have to be perform the peak element. We have to be perform Q is underflow, Q is overflow. In other words, we can be apply the Q is full or Q is empty. So these are the some operations we can be apply on the Q, or we can say that these are the operations we have to be apply on the stack. So same operations we have to be apply on the Q. So in the next lecture we have to be define the next part.